Hey everybody, and welcome to another JASP tutorial. I want to do the next continuation of the Learn Bayes module in JASP. So in JASP 0.14, I believe, maybe it was 0.13, nope, it was 0.14, they added in this Learn Bayes module. And, you know, it's an interesting module because it's supposed to teach you how to do Bayesian statistics using a lot of basic kinds of hypotheses and testing of probability and that kind of stuff. And I did the Learn Bayes module, and I believe if we go up to Learn Bayes here, it was the binomial estimation. But as you can see here, in 0.15, they added several more Learn Bayes modules, and I'm so excited. You will see me do all of them. I don't know how to do any of them, and so we're going to do this together. Do not take this video as a tutorial, because it's not a tutorial. It's me working through, maybe for your benefit. Maybe you don't like the way that I do it, and that's okay. You don't need to watch this video. But I use this as a teaching tool, so to speak. So if I ever jump into Bayesian statistics head full, hit the ground running, at least these Learn Bayes module with, Bayes' lovely picture up here, that, have some background here. And these are useful teaching modules in case you want to use JASP to teach students. So perhaps you know how to do Bayesian statistics, dear viewer, but maybe you are a teacher and your students don't know Bayesian statistics. Of course, that's not the nature of most statistical education all across the world. We're still very heavily invested into null hypothesis statistical testing and classical tests. At least in the United States, there are very few people learning Bayes at the undergraduate level, let alone in high school or other primary educational levels. But in secondary education, very rare for the United States, to teach Bayesian statistics. So, of course, that includes me, even in post-secondary education and graduate school, did not do Bayesian statistics. I tried, don't get me wrong, I tried, but it wasn't, there was no incentive for me to continue to do it, and so I ended up giving it up. So that's why I like these. Now, the version that I'm using, just to quickly, as an aside here, is the newest version as of recording, which is 0.16. So I'm a little bit behind on my 0.15 videos, so I apologize for that. But in this case, we're going to do a Learn Bayes module. And we're going to do the Learn Bayes Game of Chance under the heading Problem of Points. And so I believe these are two epis, sabers, whatever. I don't know what they're called in fencing, but they're the two swords, fencing swords. Fight to the death! So we're going to do the Game of Chance, okay? And so here we have the Game of Chance already simulated by default values, okay? So let's see. I don't know what we are doing here. So I'm going to open up the help file, and I got nothing. Okay, help file, learning Bayes. If we're going to learn Bayes, we need the help file. We need it. Okay, so none there. Now, the Learn Bayes module for the binomial estimation had a lot of flavor text, a lot of education text. So I'm a little wary about this. I'm a little wary about what I am getting myself into with this one. Okay, all right. So let's take a look at what's going on over here. All right, so we have players, the probability to win 1 point, and points gained. Okay, so do we have two players? Yes, so we have two players. We have A, B. And we can add a player, which I assume would add another column. We can delete a player, and then we can reset the whole game board. Points needed to win the game is 2, so we're essentially tied here at the outset. And number of simulated games is 500. So this is, okay, woo. The probability to win 1 point is half and half right now. Okay, so this will tell you that it looks, so the probability, so on the y-axis, so number of simulated games is on the x-axis here. So 0, and to 500, okay? So probability A wins the game is on the y-axis here. So probability is from 0 to 1. And so 50%, so it's a 50-50 since it's a game of chance, okay? Probability to win 1 point, game of chance, okay? So probability of A winning the game. So it looks like A is not going to win the game. And I assume the blue around here, player A has already won the game. Adjust the inputs. Let's say if we change that to 3. But see, over and above, B is seemingly winning the game with quite a bit more probability down here. That's so... Oh, I'm sorry. That's not B winning the game. A has a 75% chance of winning the game sort of at the end because it's 1. Now, if we change that to 2 in both cases, it goes back to 50%, but A has a better chance. If we add a player, I honestly need this to be a little bit better at explaining what I'm reading, because I'm not sure what I'm reading. So 3 players, the probability to win any single point is 33%, 33 repeating. And so I guess if you plug this into Bayes theorem, you get the probability that A is going to win 42.8%, 45.4% for B, and 11.8% for C. But how did you arrive at that over the simulated amounts of games? See, that's what I'm not getting here. So if I change this to 100, so it'll level out at 47, 42. So A has a better chance to win earlier than B or C, but B is better as it goes along. Yeah, I'm not sure. All right, maybe they're working on it. But that's the game of chance module in the Learn Bayes module. I don't know what I've learned, unfortunately. So the game of chance, sure, yeah, all right. If you like this video, consider leaving a like. I don't know why you would. If you like this content, consider subscribing for more. I'm going to do other Learn Bayes modules, so maybe stick around for those. Woo! Thanks for watching.